Introduction to normal distributions. Normal distribution is a continuous probability distribution for a random variable x. The graph of a normal distribution is called the normal curve, as shown here. Note, it is the most important continuous probability distribution in statistics. So working with normal distribution, the properties are it is a bell-shaped curve. The mean, the median, and the mode are equal. So the measure of central tendencies all have the same value. Also, it is symmetric about the center, where the mean is. So symmetric is they cut the curve directly in two equal parts at our mean. The total area under the normal curve is equal to 1, or 100%. When we're working with area in normal distribution, the area represents our probability. So probability is always a value between 0 and 1, or between 0 and 100%. So when we're doing the normal distribution in the curve, the shaded area will give us our probability. And this is key information. When we have a line of symmetry at the mean, and for a normal distribution, we always have a line of symmetry at the mean. Well, what that means is that the area to the left is equal to 50%, and the area to the right is equal to 50%. So here's the 68, 95, 99.7 rule, or also known as the empirical rule. Knowing the standard deviation, we know how spread out the data is. A 68% lies between one standard deviation and either way of the mean. So 68%, or our area under the curve, is equal to 68%. And that means that the probability is likely to happen if it's one standard deviation away from the mean. The point of reflection is where the concavity of the curve starts to change. 95% of the area under the curve is between two standard deviations away from the mean in either direction. So 95% of the area is between two standard deviations away. Therefore, if we had a probability, it would be very likely to happen. And then the 99.7% lies within three standard deviations away from the mean. So 99.7%, the probability is almost certainly going to happen. So when we have a normal distribution curve, the mean is at the center, one standard deviation away is 68% of the curve, two standard deviations is 95%, and 3 is 99.7%. So a key note here is for normal distribution, almost all the values lie within three standard deviations of the mean. So when we're working with means and standard deviations, a normal distribution can have any mean and any positive standard deviation, noted in this example here. So we have two different pictures of a normal distribution, and the mean gives us the location of the line of symmetry. Remember, the mean will always be in the center of the curve. So both of these curves, if you look at the line of symmetry, have the same mean of 3.5. The standard deviation describes the spread of data. So notice in these curves, the spread is different. You can see it in the curve. The first one is wider. The second one is slender. So when we look at this, that is caused by the standard deviation. They both have the same mean, but because the standard deviation is different, the shape is also different. So you see here with a higher standard deviation, our curve gets wider. With a smaller standard deviation, it gets thinner. So with z-scores, when we're working with normal distribution, we're going to be working with z-scores. So when we have a set of data values and they're normally distributed, we can standardize each score by converting it into a z-score. The z-score makes it easy to compare data values measured on different scales. So when we're working with the normal distribution, we want to standardize the score, and then when we standardize the score, we'll have z values. So you notice here the green one is a normal distribution. My mean is in the center where the line of symmetry is. Well, when I standardize the score, we're going to end up with z-scores, where our mean for the z value at the line of symmetry would be 0. So any normal distribution can be converted into a standard normal distribution. So what is a standard normal distribution? Standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So that's a standard normal distribution. It's also known as the z distribution. So the area under the curve, again, will total 1 or 100%. When we have a standard normal distribution, remember the mean is at the center or at the line of symmetry for the curve. So when we have a standard, our mean is 0, and then you see one standard deviation away in either direction, we get a -1 and +1, and -2, +2 for 2 standard deviations away, and then 3 standard deviations away would be a -3 and 3. So a key note that I want you to notice here is our values to the left of the mean of 0 are negative, and the values to the right of the mean are positive, like a number line. So any x or random variable can be transformed into a z-score by using this formula here, where we have the random variable minus the mean all divided by the standard deviation. So we're going to be converting normal distributions to standard normal distributions in order to compare data sets. So a key note here is the z values above the mean are positive and the z values below the mean are negative. And that's key information to keep in mind when we're working converting normal distribution to standard normal distribution. So now the properties of a standard normal distribution. So when we have the cumulative area and it's close to 0 for the z value close to a -3.9. So we're looking at this curve, and notice where the z value would be a -3.49. It's very close to the tip of the curve. And at that point, our probability or our area will be very close to 0. So the shading would be very minimal. And as we go from the left to the right, the cumulative area will increase as the z-score increases. So as we increase from a -3 to -2, our area under the curve is going to increase. As we go from -3 to -1, the area to the curve is going to increase. And a key note, again, just like normal distribution, the standard normal distribution at our mean of 0 will cut the curve into 2 equal parts. And to represent the area as the 50%, we usually use 0.5000, because when we're finding the area for a normal distribution, we will be going 4 decimal places. So at the mean of 0, that is line of symmetry, and it cuts the curve into two equal parts of 50%. So the area under the curve for the z value 0 will equal 0.5000. Now, the cumulative area is close to 1 for a z-score that's close to 3.49. Notice that when we shade until we get to the 3.9 z-score along the horizontal axis, the entire curve is shaded. Therefore, the area will be very close to 1 or 100%. So when we're looking for the area of a curve based on a z-value, we can use the normal distribution table, or the Appendix B, the standard normal table. So we can use this table to find the area, but for most we will be using the calculator. But I want to teach the table if you are using the table. So how it works is it's going to provide the z-score to one decimal place. So you want the whole part and the one decimal place, or the tenth spot, in that z-score. And then you're going to look down that column until you find that value. And then you're going to go across the row at the top until you get to the hundredth decimal spot of that z-score. So in this case, the hundredth spot is that 1, so we're looking at 0.01, and then you're going to find where they intersect. And where they intersect would be the area for that particular z-score, or the probability. So in this case, the area to the left, and that's key information for the z-score, 2.71, it would be 0.9966, or that would be our probability. So I just want you to notice, based on the properties of a standard normal distribution, where that 2.71 would lie on that curve, on that z-axis. And you see it's very close to 3. So we would think that if it's very close to 3, probability is going to be very close to 1. And you noticed here when we looked it up, we got a probability of 0.9966, which makes sense. It would be something that high based on the z-score given. So it's important to make connections of what the z-score represents in the curve, and the area represents the probability. So now we're going to be really using the calculator to find the z-score. And how you use the calculator, whether you have the 83 or 84, you're going to press your second key and you're going to hit the VARS button. Now the VARS button, above the VARS button, you see that abbreviation DISTR. Well, that represents distribution. We're working with normal distribution. We want to work in the distribution menu on the calculator. So once you get into the distribution menu, you want to make sure you're choosing the right menu option. You have to choose the number 2 option for normal CDF. And then you'll press enter and you'll come to either one of these screens. If you have a newer calculator, you're going to have the lower, upper, you're going to have the mean of 0, your standard deviation of 1, and that word paste. If you have an older calculator, you're just going to see the normal CDF, and you're going to have to fill in the parentheses. And how it works is, when we're shaded to the left, I need you to keep in mind, and I'm going to go back for a minute just so you can understand, when it's getting shaded to the left, that means it's going off indefinitely to the negative infinity. So when it's getting shaded to the left, you will be shading from the z value to the left to negative infinity. So that's important to understand, because in the calculator, the way they're representing here, that the lower value in shading to the left would be that negative infinity. And negative infinity can be represented here by that -1, that E99. It means it's going off indefinitely in the negative direction. And then your upper value would be the z-score that you're looking up. So in this case would be a -0.98. Now with the negative infinity for the 83 calculator, you can use a -10,000 versus that symbol -1E99. A -10,000 will work to get you your z-value, or the area for the z-value. So notice here, to enter in the negative number, you have to make sure that you're using the negative key. So you have to use the negative key, which is right next to the period key on the calculator. If you use the minus key, it will give you an error message. So it's very important that you use the negative key. So in the normal distribution, and you're choosing, or you have the older calculator, the first thing you're going to type in is that -10,000. You're going to need a comma to separate your z-score of that -0.98, and then you can hit enter, and you will get the area for that z-value would be 0.1635. So the area can be found by using the calculator, whether you have a newer calculator or an older calculator. And the newer calculator, you're going to have the negative infinity filled in, and then you put the z-value under the upper, and then you just enter through until you get your answer on the screen. So again, it's good to be able to visualize where that z-score is on this standard normal curve. And we have a -0.98 would be very close to a -1. So the shading there is very minimum. That's why we're getting an area of 0.1635. The probability is the area, so the probability of us getting anything from the z-value of 0.98 is like 16%. So it's really important to be able to visualize our z-scores and what kind of area we have, because a z-score that is below 0 should be less than 50%, or 0.5000. And a z-score that is above 0, a positive value, it should be above 50%, or that 0.5000. So it's important to be able to recognize how those properties work when you're finding areas for z-values. Pause and try. So in this case, you should have gotten the area is 0.9793. Pause and try. And in this case, you should have gotten 0.0008. Now in this one, you might have seen in your calculator when you did the calculation that little e with a negative number, a -4. Well, what that means, it's scientific notation. You need to take the decimal and move it over that many places of that negative number. And you're always moving to the left, so it's a very small decimal. So now here's the guidelines for finding areas. To find the area to the left of the z, you find the area that corresponds to the z in the standard normal table, or what we represent in the calculator. So when the area is shaded to the left, that's considered standard, and you would use the value you find. So in the calculator, that's where you would go from the lower value is that negative infinity, or -10,000 we could use, and then the upper value would be our z-score that we are trying to find the area for. So if you're using the older calculator, it's a -10,000 comma and your z-value you're looking for. And in the newer calculator, you leave the lower as the negative infinity, and the upper would be your z-value. When you have to find the area to the right of the z-score, and you're using the standard normal table, to find the area that corresponds to the z, you're going to have to subtract the area you find from 1. because the normal standard table always gives you the area based on the left. So when you're finding the area for a z-value, it's based on the left, and you want the area to the right. The only way to get that is to subtract it from 1. So that's important to remember if you're using the table. Now, if you're using the calculator here, the way you're going to do it in the calculator, and instead of our lower value being that negative infinity, our lower value is the z-score now. So you would put the z-value first, and then notice here when you look at the shading, it's going off indefinitely in the positive direction, so you would need to use positive infinity in the upper value, or in the second position in the older calculators. And 10,000 will represent infinity in our calculators. And then lastly, when you're finding the area between two z-scores, find the corresponding area to each z-score in the standard normal table, then subtract the smaller area from the larger. So if you're given a curve where you're giving an area between two z-values, well, you would have to find the area for each z-value in the table and then subtract them from each other. Or if you're using the calculator, you always want to make sure that you use the smaller number first, the smaller z-score, and then the larger z-score, and then you would be able to find that area. So the smaller would go in the lower, and the larger would go in the upper. And you keep the mean as 0 and the standard deviation of 1. That's a standard normal distribution. So let's find the area here, and the key thing is which direction is it shaded. And because it's shaded to the left, then all I have to do is plug it into the calculator with that negative 10,000 or the negative infinity and the z-value, and I'll find my area. And in this case, the area is 0.9535. And the area and probability are the same, so that's important to making a connection early on that when we find the area, we're really truly finding the probability, and that's what we're going to be working with in normal distribution. So this next example, notice that it's the same z-value, but it's shaded to the right. So our value for that shading is not going to be that previous one of 0.9535, because the shading isn't 95%. So it's really important that you notice what you're working with. And because it's shaded to the right, lower value is that z-score, and it's going off indefinitely to positive infinity. So you would put the z-score in the lower and the positive infinity in the upper, and then you would find that our probability or our area here would be 0.0465. And then this next example is when we have z-scores and a shading between. When the shading is between, you want to put the lower z-score in first and then the upper z-score, and then you will find that area shaded in between. And in this case, it would be 0.8479. Pause and try. So again, the shading is to the left, so you end up with a standard value of 0.1611. Pause and try. So in this case, you end up with 0.1446. Pause and try. So in this case, you should have ended up with 0.8275. So now when we're working with normal distribution and we want to find probability, if a random variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve for that interval. So how do we do this? To do it, you're going to be finding the normal probabilities. You're going to find the probability, and this is the abbreviation, the p parentheses with that particular interval. So it's really important to understand the intervals. This is x is less than b. Well, what that represents is it's getting shaded to the left. If it was x is greater than b, it would be shaded to the right. Or if we have values in between, the x will be in between two values. So when x is normally distributed, you can translate the x value to a z-score by using this formula. And you're going to use either the standard table or simply the calculators like we've been doing. So here we go, and we're going to be using the calculators in here. So the random variable x is normally distributed with a mean of 174 and a standard deviation of 20. It wants us to find the probability of our random variable being less than 170. So how we could do this is it's less than, which means it's getting shaded to the left. So when I do this, it is going from a negative infinity to this 170, and that's important information. So I can enter this all into my calculator to find the probability or the area under the curve. Again, you're going to be using that distribution menu, so you're going to need to go to second vars, and then you're going to choose the number 2, which is that normal distribution. So now when you're doing this, instead of our mean and our standard deviation being 0 and 1, we're going to convert this normal distribution that has a mean of 174 and a standard deviation of 20 to a standardized score by plugging that into our calculator. So when you plug it in, you're going to be plugging in the mean for the problem and the standard deviation from the problem. So this is what it would look like if you were plugging it in to the TI-83. For the 84, you want your lower to be that negative infinity. Your upper will be the x value that you're looking for, or the random variable. In this case, it's 170. And then you want to change the mean here from 0 to the mean in the problem, which is 174, and change the standard deviation from 1 to the standard deviation of 20. Once you have all the data entered in, it will give you the probability. It converted everything to a z-score so that we could get the probability. And in this case, the probability is 0.4207. So I want you to understand what that means. If we had a normal curve, we know that at the normal curve, the mean separated by the line of symmetry breaks the curve into two equal parts. So in this example, our mean was 174. So when we're looking for a value of 170 or less, that is on the left-hand side of 174, so we would expect that the area under the curve would be less than 50%, or that 0.5000, because remember, the line of symmetry cuts the curve into two equal parts. So you want to understand what the mean is representing here and what value you're looking for. So now when we're looking at this one where we have a random variable x is normally distributed, they're giving us the mean of 174 and a standard deviation of 20. It wants us to find the probability, and again I want you to associate probability is associated with the area. That's how we find probability in normal distribution. We find the area under the curve between those two numbers. So because it's between, we're going to use the distribution menu again, and you always need to make sure that the smaller values first, then the larger value, and you're going to change the mean and the standard deviation to the mean and standard deviation of the problem. And then you'll hit enter, and you'll have your probability, which is the area, that 0.1788. So the calculator will do the conversion for us. It's actually doing that formula to get us our probabilities based on a z-score. So this next is an example of a word problem that we will see in statistics. So we have a survey indicates that people use their cell phones an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will use their current phone for less than 1 year before buying a new one. Assume that the variable x is normally distributed. And that's important information. In order to convert it to a z-score, it has to be normally distributed. So what I'm identifying here is my mean is the 1.5 and my standard deviation is the 0.25. And what we're looking for is to find the probability of less than 1 year. So that's what the probability abbreviation would look like. We're looking to see, is our x or random variable less than 1, which means it's getting shaded to the left. And that's important to recognize. So when you're putting it in the calculator, you're going to either use that negative 10,000, or if it's already filled in as a negative 1e99, you can use that. And then the value for the random variable is x, and you want to make sure you change the mean to 1.5 and the standard deviation to 0.25. You'll hit enter and you should get your area would be, or the probability would be 0.0228. And really what that's stating is that there's a 2.28% of cell phone users will keep their phones for less than 1 year before buying a new one. So it is giving us information. It is answering the question. And this next one, we have a survey that indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in a store. The length of time spent in the store is normally distributed and is represented by the random variable x. A shopper enters the store. Find the probability the shopper will be in the store between 24 and 54 minutes. So again, this is important information if you're in marketing and you're selling a product in the supermarket and you want to know how long somebody's going to be in the store. So all of this stuff is important and we want to be able to find the actual probability of it happening. So the first thing I'm going to identify, it's normally distributed, and I found my mean is 45 and my standard deviation is 12. And because it's between, my random variable is the probability between those two numbers, 24 and 54. So when you put it in the calculator, your lower will be 24 and your upper will be 54. And then you change the mean to 45 and the standard deviation to 12, and you'll find your probability. So in this case, the probability would equal 0.7333, which is a good probability that they would be in the store that long. So now this next example, finding the probability that the shopper will be in the store more than 39 minutes. And again, we're using the same information from the previous example. More than means that it's greater than, which means that my lower value will be that random variable 39. So it's important to be able to distinguish what these inequality symbols are telling us. And when it's greater than, it means it's getting shaded to the right, which means I have to put the random variable in the lower, and then I have it to positive infinity, and that's what that 10,000 represents. Changing the mean to the 45 and the standard deviation to 12. You'll hit enter and you'll get your probability. So the probability of them being in there longer than 39 minutes is 0.6915. So pretty high chance that they're going to be in there for that time. Pause and try. So in this, it was asking us for less than 66. So when you've done this, you should have gotten a probability of 0.1205. Pause and try. And because it's between, you want to make sure that it's between those two numbers, and you ended up with a probability of 0.6945. Pause and try. And in this one, it's greater than 72, so you wanted to make sure that that 72 went into the lower limit, and it's going off to positive infinity, and your probability here is 0.1850. This next example, and I need you to be careful about how you work with these type of problems. If you have 200 shoppers enter the store, how many of the shoppers would you expect to be in the store more than 39 minutes? So, and it's the same example. We're using the mean of 45 and the standard deviation of 12. So now it's a little bit, in order for me to determine how many of the 200 shoppers that entered the store will be in the store past 39 minutes, I need to know the probability of staying in the store past 39 minutes. So in this case, the first thing you're going to have to do is find the probability of greater than 39. If you don't have the probability, then you're not going to know how to determine out of the 200 shoppers who would be left in the store. So the first thing is to find the probability. So it's greater than 39, and we find the probability to be 0.6915. Well, once you have the probability, you'll take that value and you'll multiply it to the 200 so that you can tell how many of those 200 will be left in the store. So in this case, we would get 138.3, and because we're talking about shoppers or people, we can't leave the 0.3 in our answer. So our answer really would be 138. Pause and try. So the first thing I needed to do is find the probability of shorter than 9, and we ended up with 0.3085. And then you take that probability and multiply it to the 400. So we would expect that we would have 123 fish.